everyone see my screen? I assume yes, because you're all muted.
Yeah.
And for the purposes of the recording, I will start again from the top. And I now do understand why I'm not allowed to have a Zoom account. Okay, so thanks for the kind introduction, Steve, and good morning, everybody, or good afternoon, everybody. My thanks for joining this SUT webinar. I can see a few familiar faces on the call. We live in interesting and challenging times. While we grapple with one global crisis, I want to speak today about another for which we urgently need to prepare. Without timely and effective action now, climate change will be a creeping disaster impacting us and future generations to a greater extent than COVID-19. Like the coronavirus pandemic, the impacts are global in extent. Unlike the coronavirus pandemic, they're potentially irreversible, at least over human timescales. When I started preparing this talk, I thought long and hard about whether it is appropriate to describe climate change as an existential threat. Are the consequences of inaction over greenhouse gas emissions and land use changes really a threat to the very existence of our civilization? Most of my career has been concerned with observations and numerical models of the ocean and atmosphere. As a consequence, I'm very aware of the limitations of our scientific understanding, especially when making forecasts and projections about the future. I've seen our observational capacity develop to the point where we have reliable global atmospheric and ocean monitoring, and where models have evolved to a level where they can be considered pretty robust tools for projections into the future. I'm fully convinced we do indeed face a climate emergency which demands action if we are to avoid dire consequences and a possible existential threat. COVID-19 is teaching us how fragile our society can be. Climate change is a much bigger test. In this talk, I want to do three things: convey the extent of the climate emergency and the threat it poses, review some of the options for response, and make an urgent call for action. Extinction Rebellion are not the only ones to recognize the seriousness of climate change for society. No less a body than the World Economic Forum classifies failure to mitigate and adapt to climate change and the consequent extreme weather events as the greatest global risk facing humanity. It is interesting to note in this diagram from their report the relative positions of infectious diseases compared with failure of climate change mitigation and adaptation. Climate change impacts have both a higher likelihood and a greater impact. Time precludes me providing a comprehensive review of climate science, and I'm sure you are all very familiar with the basics. Three components of anthropogenic climate change are quite certain. We know for sure that greenhouse gases emissions are rising as a result of the burning of fossil fuels, and that the concentration of carbon dioxide in the atmosphere has increased from around 280 parts per million before the Industrial Revolution to more than 400 parts per million today. We know that carbon dioxide and other greenhouse gases act to retain heat in the atmosphere. This was demonstrated way back in 1859 in John Tyndall's pioneering experimental work at the Royal Institution in London. And we know that the atmosphere has been warming since the Industrial Revolution, tracking the rise in greenhouse gas emissions. Projecting these changes into the future is less certain, but by far the largest uncertainty is knowing the future trajectory of emissions and land use changes rather than the consequent changes in global temperatures. The science is robust, the societal response to the science far less so. The risks associated with the present trajectory of the climate system are many, and they are interlinked. To illustrate the seriousness of the emergency and demonstrate how it constitutes such a major threat, I will explore just one feature, and that is the incidence of deadly heat waves. You've probably read recent reports about how these are increasing in frequency. Deadly heat waves are defined as combinations of air temperature and humidity that a human being and most other animals cannot survive. This recent Nature paper looks at the projected incidence of such conditions out to the end of the century under a range of greenhouse gas emissions and land use scenarios. This animation shows the projected evolution of deadly heat wave conditions under the RCP 8.5, or business as usual with no mitigation pathway for emissions. Under this scenario, by the end of the century, much of the land area of the planet would experience deadly heat wave conditions for significant periods. For many regions, these conditions would persist for the entire year. The obvious implication of this is that much of the planet would become uninhabitable within the expected lifetime of those born today. Thankfully, shared socioeconomic pathway 8.5 is one that present policies should ensure we avoid. But as this diagram shows, we're currently very close to the track for this pathway and still on a path to high levels of warming. Even the pledges underpinning the Paris Agreement are still a long way from delivering the target of no more than a 1.5 degrees centigrade increase in mean global temperature by the end of the century. For the ocean, the impact of climate change are no less consequential, as the ocean takes up much of the excess planetary heat and about a quarter of the additional carbon dioxide. It's warming, losing oxygen, and becoming more acidic. This has many consequences, including sea level rise, coral bleaching, rise in the incidence of toxic algal blooms, rising dead zones as a result of reduced oxygen levels, impact of acidification on calcareous organisms, and impact on fisheries. To illustrate the seriousness of these changes, I will again use the example of heat waves. Marine heat waves are already a serious problem, with widespread impacts on coral reefs, kelp forests, and seagrass beds. This very recent paper projects the changes in the incidence of marine heat waves in much the same way as that shown earlier for air temperatures. For the RCP 8.5 business as usual scenario, the outcome is catastrophic, with more than 90% of the upper ocean projected to be under permanent marine heat wave conditions by the end of the century. Even for the RCP 4.5 reduced emissions scenario, about 50% of the upper ocean is projected to be in permanent marine heat wave state by 2100. Why is the 1.5 degree target so important? I'm sure you're all familiar with this metaphor for failure to react to gradual changes. To extend the metaphor for response to climate change, we're approaching circumstances where a lid is placed on the saucepan, preventing the frog from even having the opportunity to escape. We're approaching, and in some cases may already have passed, tipping points, resulting in irreversible changes to the climate system. This November 2019 Nature article forcibly makes the point about the risks associated with tipping points and how dangerously close we are to transgressing them. There is growing recognition also of the potential for domino effects, with transgressing one tipping point triggering the next through the highly nonlinear connections within the climate system. Nowhere is the tipping point risk more evident than in the Arctic, where air temperatures are increasing at more than twice the rate for the rest of the planet, and where sea ice cover has been in continual decline, reaching its lowest ever observed extent in late summer of last year. Annual Arctic sea ice volume has been in decline for all of the last 5 decades, with projections indicating a completely ice-free late summer Arctic as early as 2025. As ice loss exposes open water, this darker surface has a much lower albedo, resulting in much reduced reflection of solar radiation. In terms of warming, albedo loss reductions have had roughly the same effect as the past 25 years of carbon dioxide emissions. As air and water temperatures rise, the risk of permafrost melting on land and in shallow water increases, with a corresponding risk of large quantities of methane, a highly potent greenhouse gas. Temperature rises are driving the melting of the Greenland ice sheet, currently adding approximately 1 millimeter per year to the current 3 millimeters per year of global mean sea level rise. As the ice sheet reduces in elevation, this may become irreversible, leading to an eventual 7-meter rise in mean sea level. And rapid warming is altering jet stream circulation, with impacts on the climate of the entire Northern Hemisphere. Then there is the risk of irreversible changes to the global thermohaline circulation, as more and more fresh water is released in the Arctic region. This could change the these circulation patterns, with the warm water of the North Atlantic current controlling European temperatures, into this. There is compelling evidence in the geological record that this has happened in the past. Could it happen as a consequence of greenhouse warming? We're not sure. From more than 50 years of salinity measurements, we do know that fresh water is accumulating in the critical areas of the North Atlantic, and that this fresh water is making the waters less dense in the layers that feed the ocean conveyor and keep it moving. Measurements of the meridional overturning circulation in the Atlantic indicate that it has weakened over the last 20 years. The Arctic has been described as the canary in the climate system. Further interconnected tipping points are the destruction of boreal forests, the Amazon and other forested areas, mobilization of methane from permafrost across the Arctic region, and progressive loss of the world's coral reefs, and a reduction in Antarctic ice shelves, leading to mass loss from the Antarctic ice sheet, further exaggerating rises in sea level. So can our metaphorical frog escape? Well, the answer is yes, but the time to act is now very short. We really do have only a decade or so to take action to avoid the extreme threat we face. Inaction in the past few decades means that the scale of the response now needed is enormous. Without this response, we've lost the chance to limit global temperature rise to the Paris target of 1.5 degrees and lost the opportunity to avoid the risk of major climate tipping points. We do not lack the means to respond, just the will. The transition from fossil fuels to renewable forms of energy is already underway, as this slide from the latest BP Energy Outlook shows. To cite just the example of power generation, the cost of renewable energy from wind and solar has dropped to be at or below that of all types of fossil fuel generation, but the challenge of substitution is large. This can only happen if there are large changes in policy and a huge shift in investment. It is almost certainly too late to deliver sufficient mitigation to avoid the most damaging impacts. Even the most optimistic scenarios in the recent IPCC report on limiting global warming to 1.5 degrees demand a degree of geoengineering or active carbon removal from the atmosphere, which takes us into the territory of active solar radiation management. Ideas being explored include proposals for refreezing the Arctic by artificially managing its albedo, or the introduction of reflective material into the upper atmosphere, mimicking the cooling effects of large volcanic eruptions. Solar radiation management is a scary option, with the potential for many unforeseen consequences. But it's attractive because it's relatively inexpensive. It's scary because it would involve actively managing the levels of solar radiation reflected into space. It has been difficult enough to model the effects of our present inadvertent large-scale solar radiation experiment of introducing greenhouse gases into the atmosphere. Actively managing the climate in this way would be immensely challenging, with winners and losers, and an indefinite and growing commitment to its delivery, if we use it as an opportunity to continue with business as usual use of fossil fuels. Nevertheless, it's being seriously and actively proposed, with the option of use of tethered balloons being the most likely route to its use. For the oceans, it would be a disaster. Acidification would continue at an ever-increasing rate, reaching levels likely to have major impacts on marine organisms well before the end of this century. More acceptable and implicit in the Paris COP21 agreement is biomass energy with carbon capture and storage. Trees and other plants do a pretty good job of this, but the scale of reforestation that would be needed is mind-boggling. Think of the millions of years of sunlight it took to capture the carbon being released from the fossil plants and animals we're currently burning as coal, oil, and gas. While planting trees remains a good idea, and the Trillion Trees campaign will certainly help, we need much more than this. But directly removing carbon dioxide from the atmosphere is a bit like trying to make eggs from omelettes. It's much easier to burn concentrated sources of carbon, such as coal, oil, and natural gas, than it is to remove the resulting highly diffuse carbon dioxide in the atmosphere. But it's starting to happen. I offset my personal carbon emissions with one of the pioneering initiatives in direct carbon dioxide capture from the atmosphere. Climeworks is the first large-scale commercial direct capture system, extracting carbon dioxide from the atmosphere using geothermal power, then pumping it deep underground where it reacts with hot basalt rocks to form carbonate stone, literally turning atmospheric carbon dioxide into solid rock. Such systems need to be scaled rapidly to help fill the gaps in mitigation efforts. Carbon capture and storage beneath the seabed, making use of depleted subsea gas reservoirs, is another option already being conducted on a small scale, and likely to be scaled up significantly in the future. Only last week, Equinor, Shell, and Total agreed plans to build a large carbon capture and storage system for the North Sea, the Northern Lights project. It is one of many marine geoengineering possibilities. To start to bring this short talk to a conclusion, we're at a fork in the road, needing to make an imminent choice of the future we want for us, our children, and our children's children. Making a choice between the best of worlds and the worst of worlds. Scenario planning by the World Economic Forum paints a scarily familiar picture of the worst of worlds possibilities in their World of Walls scenario. This scenario has some frightening parallels with what we're seeing play out on the world stage right now. Any of this sound familiar? It does not have to be this way. We do not have to accept living in a Mad Max world. We have the tools and capabilities to deliver something much more positive for us and future generations. As is forcibly argued in this 2020 opinion piece in Nature, we need a renewed commitment to the Sustainable Development Goals. The only thing preventing their delivery is the political and societal will to do so. Plato is reputed to have coined the phrase, "Storytellers rule the world." We need a new narrative driving our choice of future. So to end on a lighter note, we all need to strive not to act like the metaphorical frog and to persuade others likewise. Thank you for listening. Can you still hear me? Does anyone have any questions?
All right. Anyone have any questions for Ralph? I can unmute you. I can unmute you all. I think we're a safe group now.
It's the first time I've seen a Zoom bomb happen.
Yes, indeed. Yes.
Right, I had to work out who that guy was.
No. Mind you, it'll be on the video because of course I was recording it earlier.
Yeah, so we've got his identification.
We've got his ID.
He logged in as, so we can probably track him down and Zoom bomb him.
Yeah, indeed. Right. So anybody got anything they want to ask Ralph?
Hi, Ralph. This is Jagdish here.
Hi.
I've got a quite interesting carbon capture technology we are going to implement by the Equinor and other. How best we can monitor the carbon dioxide release in that environment? What's the easiest way for allocating those technology in specific areas?
Well, the one that Equinor are developing is specifically concerned with capturing carbon dioxide and injecting it into depleted gas reservoirs. So that technology is fairly well proven in a couple of small-scale schemes, but what they announced last week was scaling that up quite significantly. We're fortunate in Europe that we have got quite a large potential for that form of storage because we've extracted so much gas from large subsea reservoirs. But that's a fairly unusual resource. I think the more likely route is the sort of example I showed earlier, where you direct carbon capture and then you find some way of either locking that away in solid rock, as in the case I showed, but there are very few places you can do that. That particular scheme's being built in Iceland, where of course they've got huge access to geothermal power. The alternative, one of the other alternatives being explored, is actually turning it into a combustible fuel. So you can actually turn carbon dioxide back into a hydrocarbon and burn it as a fuel. That's obviously not locking it up indefinitely, and it has a small positive carbon impact, but it's much reduced compared with conventional fossil fuels. So there's lots of options. The big challenge with all of them is the scale that you need to do it on is truly enormous. You know,
cost involved, isn't it?
To do what they're doing in Iceland on a scale where it'd really make a difference, I suspect you'd have to cover half of Iceland with air extraction plants.
That's good. Thanks.
Okay, thank you. Anyone else with a question for Ralph?
Ralph, this is it's a behavioural thing as far as most people in society in Western world. What do you think would help make those behavioural changes in what we do, in to make the biggest difference to these problems?
I think in part what we're currently experiencing. I think if nothing else, what we're experiencing with coronavirus is demonstrating just how fragile our societal systems are. And I think it's going to make it very difficult to make the argument that somehow we'll just solve the problem with some future technology that we haven't yet invented, or we'll just magically get over it. I think the present position we're now confronted with is going to force politicians and the public to start thinking pretty hard about responding to serious threats. But of course, in this particular case, we've got to respond because, as I started out saying at the beginning, there's a reasonable chance we'll get over coronavirus in maybe 2 or 3 years. If we go too far down the climate change route, then I think we've put ourselves in a position where our present civilization would pretty much fall apart, and it's difficult to see. So the urgency is much, much greater. I think there is a mood swing. I mean, a change of mood. You look at what Extinction Rebellion have done. You look at the engagement and mobilization of young people who, of course, are going to bear the brunt of the effects. They've been mobilized on a pretty big scale, and in due course, they're going to have a pretty big political and societal influence. You just have to hope that that comes quickly enough.
Thank you.
I've got one. Ralph, I was going to ask, you talked about the equatorial regions becoming uninhabitable or potentially suffering heatwave stress, and the implication of that being forced migration potentially. Do you think that could act as a positive lever in the developing world to say, this is one of the reasons we need to act earlier to avoid large-scale mass migration from equatorial regions?
Well, of course, that's been recognized as a huge problem and risk for a long time. There were reports written in the Pentagon many years ago about the global impact of mass migration as a result of climate change. The problem is making sure that the right action is taken in response to that. Now, of course, on the other side of the Atlantic at the moment, what we're seeing is the exact reverse response. Let's just build more walls. Providing we can overcome that sort of response and get to the point of recognizing that this is a global problem that does demand a global response, then yes, I think that's one of the forces that will cause developed countries to take a different view, because one way or another, even if you do build walls, that threat becomes extremely large.
Thank you.
Okay, thanks. Any more questions for Ralph?
Got one more question, Ralph.
Fire away.
The one of the slide you highlighted, the sea level rise going to be like 7.2 meters if this goes exponentially. What all implications that can cause? For example, these cyclones, will that be extreme more, or the islands will? I'm sure the islands will have the flooding, but do you think this is related to the extreme event happening?
Okay, so I'll tackle that in 2 parts. The sea level rise question is one of the facets of climate change about which we can now do very little. Sea level rise is locked into the system for a long time to come. It's highly likely we'll see rises of the order of 1 meter or more between now and the end of this century. 1 meter has a massive impact. Everyone thinks in terms of the impact on places like London, but there are literally thousands of cities around the world that would be vulnerable to a 1 meter rise in mean sea level. How quickly we would go from that to the 7 meters that would result from the melting of the Greenland ice cap, or even worse, the potential contribution of any significant melt of the Antarctic ice cap, which, if it melted in its entirety, would add 20 meters of sea level to sea level. How quickly we move to those larger rises is extremely difficult to predict. But what we can say for certain is that the rate of rise of sea level is rising quite steeply. Then to the question of extreme events. If you add more heat to the atmosphere and you add more heat to the oceans, it's a pretty strong certainty that you will make extreme weather events more frequent. It's much, much more difficult to say anything really concise about the distribution of those extreme events. But you're just putting more energy into the system, and put more energy into the system and it will behave in a more energetic way. So yes, extreme events come with the whole process of increasing temperatures in the atmosphere and temperatures in the ocean.
Yeah, thanks.
Okay, thank you. Any more questions? No, I think that's probably it. So thank you very much, everybody. And sorry about the interesting experience earlier for those of you who were there. I have recorded this second version and we'll be posting this online on YouTube later. I'll share the link on the SUT, Twitter, LinkedIn, etc. for listeners. So thank you very much, Ralph, for...
Well, my thanks to everyone for listening, and thanks for the questions, and very good to see you all, if only virtually, on screen.
Yes, okay then. And I should comment, for those of you who've not seen Ralph's working office before, he does have the most spectacular piece of marine technology on that shelf behind him. Would you care to describe to people what it is, for those who don't recognise?
It's an Ekman current meter. So it's a mechanical current meter for making measurements of current, speed and direction, dangled on a wire, run by clockwork, and it actually measures currents by counting ball bearings dropping through a perforated tray as a rotor rotates in the current, and they drop into segments of the tray depending on which direction the instrument is oriented in. And it was used as the first instrument to try to understand the so-called Ekman effect in surface waters, and was used for a long time alongside other similar mechanical current meters as the only means we had for recording currents in the ocean. Obviously long since replaced with some much more sophisticated equipment. But a beautiful piece of engineering.
Excellent. There you go. See, we'll be spying on all your living rooms and offices now when we're watching you. Marvelous. Okay, thanks very much, Ralph. I'll end that there. Yes, and I'll upload the clean version, so to speak, on appropriate media shortly. Thanks very much.
Okay, good to speak to you.
Thank you.
Thanks.
Bye.
Bye bye.